Hello viewers, I hope you doing well so far with your studies and preparation for exams. I'm back again, Mr. Nyati, with another video which is going to basically look at organic chemistry, and this is GCE 2024 past paper. Apparently I've decided to put this because of a stamp which is here, so I don't want you to pay attention to where this or it belongs. So I just want you to focus on what I'm going to deliver. So this is GC 2024, and I'm going to basically look at question. Remember, we did most of the questions in this paper, if not all, except for section C. I want us to look at section C3, which is this question here. So I request that you like this video, share, and also subscribe to my YouTube channel. And also I would love you to basically give me feedback through your comment in the comment section. So let's get started. The question says, the following table shows the soil pH ranges required by different crops for growth. Okay, so there is a table which basically shows the soil pH ranges, and these soil pH ranges are basically required for the proper growth of some crops. So here is the table, and you have a crop and the pH range. So you have peanut, which is 5 to 6.5. So maybe we know what a pH is. A pH basically, it is one which is used to determine the alkalinity or acidity of a substance. In this case, we are talking about a range which ranges from 0 to 14, and its middle point, which is basically 7, represents a neutrality, or the neutral part of any substance, or its neutrality basically. So what we are saying here is that from 0 all the way to 7 or below 7, we're talking about a substance being acidic, and then above 7 we're basically saying that this substance is alkaline. Okay, so having said that, we can now tell that peanut grows in a pH range of 5 to 6.5. What this means is that it grows well in acidic conditions. Millet as well grows well in acidic conditions, and then we have sunflower, which grows well in acidic conditions to alkaline, between there. So neutral conditions are good for sunflower, and also slightly above neutral, which is alkaline, and also acidic conditions ranging from 6.0 to 7.5. Paprika basically grows in neutral conditions, starting from soils that are neutral to soils that have a pH of about 8.5, which is basically alkaline. And then mango grows between 5.5 and 6, which is basically acidic. So mango, millet, and peanut would basically thrive in acidic conditions with the respective pH ranges. So now let's get to the question. A farmer plants peanut and millet crops. So there is peanut and millet crop. So we go back to the table. Peanut, its range is 5.0 to 6.5. Millet 6.0 to 6.5. Almost the same. Only peanut grows well. What does this mean? It simply means that from 5.0 to 6.5, peanut grows well, but millet, whose range is 6.0 to 6.5, does not grow well. What does this tell us? It tells us that Well, the exact pH for peanut would be from 5.0 all the way to the pH which is slightly below the starting range of millet. What do I mean? It would say that from 5.0 to all the way 5.9. Why? Because at 6.0 millet begins to grow well, but here we are told that this condition only allows peanut to grow. So from this information we can say that for peanut, the acidic condition or the pH range should range from 5.0 to 5.9. Why? Because at 6.0, this is for millet, and it doesn't grow well in the same area. I hope you are getting that. So now we are told to say predict the pH of the soil. So we can say that the pH of the soil is 5.0 to 5.9. Why? Because for millet it's 6.0 and didn't grow well, even though peanut ranges from 5.0 to 6.5. So it means that the pH scale, the pH range is slightly below 6.0, but it should start from 5.0 to slightly below 6.0, which is basically 5.0 all the way to 5.9. That would be the answer. The answer should range from there. So question C3, A, Roman numero 1, we are told that the answer should be, from what we have gathered here, the answer should be from 5.0 to 5.9. Okay, so we continue. Which other crop is most likely to grow well in the same soil? So which, apart from this peanut, from the soil that we have actually determined using the information in the table above, of saying that the condition or the pH range is 5.0 to 5.9, which other one can grow well in the same soil? So we go in the table and try to find out if there is anyone whose pH range is either from 5 to either 5.9 or 6.0. So we go and check. Then we find that millet, of course, millet we've been told that it doesn't grow. Sunflower, we are told that it is the same range. The starting range is the same as for millet. 7.40 for paprika, no. And then mango is 5.5. So to 6.0. So mango would also thrive well in this condition of the soil, which is 5.0 to all the way 6.0. It would thrive well from the information that is being described in the question. So which other crop is most likely to grow well in the same soil? So we would say mango. Roman numero 2, the answer is mango. Now, I must mention that when you're answering such questions, please dwell much on the table, because most of the times answers are basically in the table or on the table, and you do well to understand what the questions are looking for. Okay, we move forward. Suggest what should be done to the same soil by the farmer in order for him to grow paprika. So we've discovered that this soil, its pH ranges from 5.0 to 5.9 because of what we've been taught. Which one grows well? Peanut grows well. And we've been taught that peanut is the only one which grows well. But millet, whose pH ranges from 6.0 to 6.5, does not grow well. So, meaning that this soil does not reach 6.5 as it is indicated here, but it is slightly below millet. So we are told that we've found that 5.0 to 5.9, that is the condition of the soil. So now we are told that Suggest what should be done to the same soil whose pH range is 5.0 to 5.9, or to the same acidic soil by the farmer in order for him to grow paprika. So paprika grows well in alkaline soils. So what we are saying here is that we need to neutralize the acidic soil for us to accommodate the growth of paprika. So what it means therefore is that we need to add something which is going to neutralize the soil. And when we are looking at chemicals that basically neutralize acidic soil, one of them is lime. Actually, it's the best. So the answer here would be, if we are to correctly suggest, would say add lime to the soil. Add lime to the soil. If not lime, you can also say add ashes to the soil, because the ashes contain the alkaline part that is needed for the neutralization of an acidic soil, for acidic soils. We go to B. B says ammonium nitrate, which is this, is one compound which is added to the soil by many farmers. Yes, because of one reason. Explain why ammonium nitrate is added to the soil. So when you are reading a question, basically, you should be able to start asking yourself questions before you read the questions. Here is a statement. Ammonium nitrate here is one compound which is added to the soil by many farmers. Is it true? Yes, it is true. Now you should start thinking, why is it so? And when you read further, you discover that the question is even there. So that one gives you a preparation to answer question. Do not be ambushed by questions. You know, there are times when questions ambush you. You read a statement, then you go direct to the question, and you find that the question itself chokes your mind, and you begin to fail to answer any question, because you've been frightened by the question. So take your time, be calm when you are reading questions, and you'll be able to answer questions easily. So now explain why ammonium nitrate is added to the soil. Well, what does ammonium nitrate contain? That which is so important to the plant that it enables the plant to grow well. So you need to know that ammonium nitrate contains the following. There is nitrogen, there is hydrogen, there is nitrogen, there is oxygen. But which one is important here for the growth of a plant? Well, you need to understand that nitrogen is one of the elements which is vitally important for a plant to grow, okay? So we're going to say it contains nitrogen, which is needed for plant growth. So for question B, we'll say, so it contains nitrogen which is needed for plant growth. That is the answer. We move on to the next question. We go to question C. Question C says, the diagram shows part of nylon, a condensation polymer. Well, you need to know that there are two types of polymers basically. We have condensation polymers. Before we go to condensation polymers, so we need to understand that there are two types of polymers. The first one is artificial polymers or synthetic polymers. The second one is macromolecules, okay, or natural polymers. So when we talk about polymers, we need to understand that there are two types: synthetic or artificial and natural. So under synthetic, there are two that we look at. One, addition. The other one is condensation. Okay? Now, additional polymers are basically polymers which have monomers that are repeated. Okay? A long chain of monomers repeated and because they are joined together to form one large molecule which we call a polymer. Okay, but when we talk about condensation polymers, we are basically talking about small units, basically 2 units, which combine to form a large molecule with the elimination of a water molecule. So under condensation polymers, there are 2 that we look at. One is nylon, nylon 66. I'll tell you what this 66 stands for. And SDA, sometimes you may think, each swango shani. That's just a joke. Nylon 66, and then the other one is terylene. All right, these 2, they are very important because these are the ones which normally come in the exams, and they usually confuse a lot. So before we go to these, these are basically condensation polymers, the natural or polymers or macromolecules, macromolecules. Okay, this is where we find even a protein, starch, okay, fatty acids, and glycerol and things like those. But here we have a serious issue to talk about here under condensation polymers, which is under a type of synthetic polymers. So what basically are we going to talk about? We're going to talk about these 2. Okay, one is nylon. Now, why is nylon? I said that nylon is said to be nylon 66. Why? Because the two monomers of nylon, each has 6 carbon atoms, okay? And that is why it is called nylon 66, okay? Each of the 2 has 6 carbon atoms, and normally we write them in a certain way. So what you need to understand is that what are the 2 monomers, okay? The first one is diamine, okay? Diamine, this is the first monomer. The other one is decarboxylic acid, okay? The dicarboxylic acid, okay? But the 5124 science syllabus uses dioic, and this is basically from the carboxylic acid, okay? Di means 2, okay? So even here, di means 2. So you have this amine group, which has, you have this molecule, this monomer, which has 2 amine groups on each end. Even this one has 2 carboxyl groups on each end. All right, is that understood? So now, we normally use boxes to indicate the 6 carbon atoms, all right? And then we are going to indicate the amine like this, and H this side, even this one, and H this side, like so. So this is what we call diamine, because of these 2 amine groups which are on both ends. So this one will combine with a dioic, okay? This one also has, 4 carbon atoms. Then when we include this one makes it 5, and an OH this side. And again we have a C, okay? And an OH this side. So this one is what we call a dioic or dicarboxylic acid. Now, this one has 4 carbon atoms plus these 2 to make it 6. This one has 6 carbon atoms, okay? So this is what you should know. So if you are told to write the chemical formula or the molecular formula, you need to know that first you need to deal with these 6 carbon atoms. So you need to write C Okay, now remember, each carbon is bonded to 2 hydrogen atoms, because it's a situation like this. 6 of them, then you have hydrogen atoms bonded to each of the sides in terms of up and down. So you need to put 2 here, then you need to show that how are they bonded now. That is the other thing. So you need to make sure that you put this one in brackets, okay? You put this one in brackets and you put your 6 here to indicate the 6 carbon atoms and the 12 hydrogen atoms that are bonded to all the 6 carbon atoms. Then now you come to these. These ones you are going to write N. Now remember, N has 2 hydrogen atoms. Now because there are 2, so for you to do it properly, you put it in brackets like this and you put a 2. This is for diamine, okay? What about this one? This one you need to also understand that you have 4 carbon atoms here which are bonded to 8 hydrogen atoms. So it's okay when you write like this, CH2 in brackets, then you put your 4 there. What else do you have? Okay, you need to understand that you have a carbon on each side. Okay, you have a carbon on each side and the 2 hydrogen atoms like that, bonded to another 2 oxygen atoms, and then you have a hydrogen. But remember that these, they are 2, okay, they are in a pair, so you need to put this in brackets. This is for dioic, okay? If you are asked to write the chemical formulae of these, this is how you write them. Now the question is, how is the bonding? How does the bonding take place? Well, remember, we had said that this one represents 6 carbon atoms. Then we have an amine group here. Okay. Here, this side is the same case. And this so. So when this combines with this, well, what you need to know is that this is what you are going to get. OH. OH. This is what you are going to get. Remember, a water molecule must be eliminated in the process. So we are going to have this being eliminated in the process to form a water molecule. And these 2 will combine. And when they combine, this is what is going to be formed. Okay, we will remove this side because we assume that another one has combined with it, another dioic has combined with it to form a water molecule. So instead, we will just indicate a bond, an N like that, H, then we put this like that, and then our N is recognized there because it's there. But we will not put this, but we are going to recognize this C here. So it depends with how we want it, for it to look smart. If you want, you can change so that this one goes up like so, so that you have another carbon, a set of carbon, 4 of them. Then you have this, okay? And then if you like, it goes down, doesn't matter really. Then it continues with another one like this. Now, this one here, we call this as an amide linkage, okay? That's one thing you need to understand about this, okay? So now, we call this one as an amide linkage. Now we need to make a difference here so that these 2, they don't look the same. We're going to shade this one and leave that one. We shade this one and leave that one so that it makes sense. And so this one now is going to be called nylon 6,6, okay? Because of the 6 carbon atoms and these 2, 1 plus 1 plus 4 here, 6. This one now is nylon. And so in the process, you are going to have amide linkages linking up the diamine and the dioic monomers. And the other product that is going to be produced, of course, it is the water molecule. Now, nylon is also called a polyamide. Why? Because it has a lot of amide linkages that make it a molecule, that link its monomers to make it a molecule. So now, having talked about this, I think we can now go back to the question. So the question now says, the diagram shows part of nylon, a condensation polymer. It's true. In the process of forming this molecule, we have water molecules being eliminated. Okay? So we have this. Now remember, this is the amine linkage, the amide linkage, and we have 4 carbon atoms. These 4 here, remember, this 4 outside here represents for everything inside. So we have 8 hydrogen atoms bonded to 4 carbon atoms, plus these 2 to make it 6 carbon atoms for 1 monomer. Even this side we have 6 carbon atoms and 12 hydrogen atoms bonded to each of the 12 hydrogen atoms bonded to the 6 carbon atoms, meaning that 2 bonded to each carbon atom, 2 hydrogen atoms bonded to each carbon atom. So we have, this is also another monomer. So this series continues repeating itself like that. So if you are asked to say how many repeating units are here, well, here we have only 1 repeating unit. Okay? It's going to be funny if you are going to say we have 2 repeating units here. If you have, let me just put this like this. So if I asked a question here to say how many repeating units are here, well, you have this monomer and this monomer forming up nylon molecule. Okay? Again, you have this monomer and this monomer forming this. So 2 repeating units here are seen. Okay? You have this as 1 unit. Okay? This as 1 unit. You have also this as another unit. So the most important thing is to see where this one ends and where this one starts from. So in this case, you have this and this and this, showing 2 repeating units. Okay, so even in this question, you should be able to identify the number of repeating units. Well, you have this one here, this one coming up again, okay, and you have this one. Now check here, you have the carbon ending, carbon beginning. Okay, this forms 1 repeating unit. So here we have 2 repeating units. That's one thing you need to know. Okay, so now, having talked about that, the question now comes to say, deduce the chemical formula of the 2 monomers. Well, the 2 monomers of nylon, like we said, it's diamine and dioic. Just like we indicated earlier, one of the 2, like what I mean here is that these 2 are the chemical formula, or depending on the way you write them, but possibly representing or presenting all the atoms involved here. But this is the best way you can use for you to arrive at your answer. So deducing the chemical formula would be this way: CH2, then we have brackets here, 6NH2 brackets, and remember this is diamine, and then you also have CH4 in brackets, no, 2 here, so that you have a 4 there, then you have CO2H, and then you put this in brackets. So this is dioic, this is diamine. This is the deduced chemical formula of the 2 monomers of nylon. We proceed with the question, draw the displayed molecular structures of the 2 monomers. Well, what you need to know is that the displayed formula or structures, Depending on who taught you first, it depends. But the best is this. I would say that you draw this, but maybe ECZ would say no, we want all the carbons shown, all the carbon atoms and all the hydrogen atoms shown. So for diamine, basically this is the displayed formula. So you have 1, 2, 3, 4, 5, 6 carbon atoms. Then you have an amine group here. Okay, even this side. Okay, then you have the hydrogen atoms now being shown here, bonded to the 6 carbon atoms. So this is how ECZ would want it. Please don't play games with ECZ. ECZ, you show them what they want. Do not show them what you want, but you show them what they basically want. This is diamine. And then the other one is now this one, 1, 2, 3, 4. Then you have C here, O, you have O, and H this side. Okay, another C here, you have O and H. Look at this. I'm not starting with H this side. I'm showing the O bonded to the next carbon, even this side, the oxygen bonded to the next carbon. Then now you show all the hydrogen atoms bonded to each and every carbon that is present. Okay, and this is dioic. This is dioic. Okay, so these are the two structural formulae of the two monomers. Okay, this is the displayed molecular structure, and then this is the chemical formula of the two. Okay, respectively, with the which one started first. So this one is diamine. This one is the displayed molecular structure of diamine. This one is for dioic, and this one is also the displayed molecular structure of dioic. We move on to the next question. The next question is that fishing nets used to be made from natural fibers. Let me read this one again. Fishing nets used to be made from natural fibers. I don't know whether I should read fishing nets were used or are used to be made from natural fibers. This sentence does not make sense for me somehow. But let's continue. Many nets are now made from nylon. Yeah, are now, meaning they were. Okay, suggest one advantage and one disadvantage of using nylon rather than natural fiber to make fishing nets. Well, what you need to understand is that nylon, because we're looking at an advantage of using, suggest one advantage of using nylon rather than fiber, natural fiber. Well, nylon is cheaper. Okay, it is cheaper and it does not require a lot of resources for it to be produced. So it is cheaper and easy to produce. When you go to another advantage is that nylon is basically stronger than fiber. By far, it is far much stronger than fiber. And then the disadvantage is that basically nylon is non-biodegradable. What do you mean? You cannot decompose it using bacteria. So it remains as a pen, okay, on your neck. You continue being with it, failing to dispose it off. So that is a disadvantage basically of nylon. It doesn't decompose easily and basically it is non-biodegradable. So to answer that, we can put the answers here to say, that was question what? Question D. We can say advantage. We can say nylon is cheaper and easy to produce. The other advantage is that nylon is stronger than fiber or natural fiber. Okay, what about the disadvantage? Disadvantage, well, we are saying that nylon is non-biodegradable. Okay, nylon is non-biodegradable. If you don't want to use that word, you can say it is not easier. It is not easily decomposed. Okay, it is not easier to decompose. So this is basically one of the answers, or this is how you answer this question which came in 2024 on in organic chemistry, and I hope you find this question helpful. Please leave a comment in the comment section so that I see whether this is helpful to you even as you prepare for examinations. I hope this was helpful. Thank you and bye-bye.